Number 19 says if we have 12.8 grams of calcium carbonate at a temperature of 38 degrees C, and we know when we see degrees C, we add 273 to give us Kelvin. Okay, our pressure is 0.96 atmospheres. Okay, we want to know how many decimeters cubed of carbon dioxide are formed. Okay, we are non-STP because we're at 38 degrees Celsius. So therefore, and we're looking for volume, so if we're non-STP, we're going to be looking for liters, so we do stoichiometry and then ideal gas. So we're going to start out with the 12.8 grams of calcium carbonate. And we're going to go from known to mole. So grams on top, grams on bottom. And we always convert to 1 mole of calcium carbonate. Okay. We'll use our periodic table and our calculators to find the periodic table mass of calcium carbonate. Calcium is 40.08 plus a carbon at 12.01 plus 3 oxygens, giving us a molar mass of 100.09 grams. After known to mole, the next step is mole-to-mole ratio. Since moles of calcium carbonate are on top, moles of calcium carbonate go on bottom. And then we are trying to find carbon dioxide. Okay, our balanced equation is 1 to 1. We're going to stop right there because we are non-STP. We're going to get an answer. So, we're going to do 12.8 divided by 100.09. Okay, and we had 3 sig figs, so we're going to end up with 3 sig figs. 0.128. And that is moles of carbon dioxide. After stoichiometry, we do ideal gas. So we already have our pressure, we have a temperature, we know our N, we just found that as our moles. So 0.128 moles of carbon dioxide. Okay, so we have our P, our V is what we're looking for. That's going to be in decimeters cubed, because that's what the problem asks for, decimeters cubed. And then we have the R. This is where it gets tricky. You're in decimeters cubed, so we're going to use the 8.315 kPa times decimeters cubed divided by moles times Kelvin. Okay, well since this R is in kPa, we have to change this to from atmospheres to kPa. So for every 1 atmosphere, there's 101.325 kPa. Okay, so we just plug that into our calculator. 0.96 times 101.325. Keeping with 2 sig figs, we're just going to have 97 kPa. So then we're going to plug that into ideal gas. So we have 97. We don't know our volume. Our N is 0.128 moles. Our R, 8.315. And then our temperature is 311. Okay, and then we just solve for volume. So we do times 8.315 times 311 divided by 97. Okay, so calculator work. So we got our raw answer of 3.12. We look at the original problem for significant figures. So we go right in, that has 3, that has 2, so we're going to go with 2. So we have 0.4 decimeters cubed.